I suppose. So what is it that we were doing before break, right? Well, we were learning about quadratic functions, okay? And when we talk about functions, most of the time, you guys might think back to like y equals mx plus b, and it's a linear function because that's the one that you spent the most time with, especially when you took linear algebra in 8th grade. We did a lot of it in nonlinear algebra in 9th grade, right? Or whichever, your math sequence was. Every high school is even a little different on the order of math classes. So we were looking at quadratic functions, and that's like the original, right? Y equals x squared, which if you think to like y equals mx plus b, we know that that's a linear function, but remember we had point slope form, and the parent function of this is actually y equals x, right? So like that's it broken down to the bare minimum of like, well, what is it, right? So same thing here, and quadratic functions are a parabola, so they look like this. So that's what we were learning about, okay? Other pieces to it, like if we have a parabola that's this way, or one that's this way, we would have a minimum point or a max point, and then we have that axis of symmetry that goes through the middle. So we usually abbreviate that AOS, axis of symmetry. Okay. So that's what that is. And then we have the different forms. So we talked about standard form, and then vertex form and intercept form. Okay. You don't necessarily have to rewrite all of these down if you don't want to. We wrote them down before. I just thought I'd rewrite them. And an example of something that we were learning. So we did learn from going from factored form to standard form, and just by multiplying. So however you multiply, so we have y equals x minus 2 times x plus 4. And you don't necessarily have to write down factored to standard form. If you're taking notes right now, you could just write the numbers down. I just do that just so you can kind of see, well, what is it that we're doing? If you look at my notes later, or for somebody who missed class too, something like that. But there is either the two methods, right? So we talked about the box method. And there's a lot of you box method people out there. I was never a box method person, but I think most of you are, depending on how your teachers have taught you before. So what you would do is you put x and minus 2 on the sides, and then x and 4, if you have them flipped around, whatever. Okay. And then you take x times x, so that's x squared. 4 times x is 4x. X times negative 2 is minus 2x. And 4 times negative 2 is negative 8. So I'm going to stop right there for the box method, and I'm going to do a switch over to the distributing method for those of you who do that or even just want to see that way. So you would take x and multiply it to both terms in the other parentheses. So x times x is x squared, and x times 4 is 4x. And then you would take the negative 2 and multiply it to both. So that'd be minus 2x, and then negative 2 times 4 is minus 8. Okay. So if you were doing the box method, at this step, then you would need to write each of these up. It really doesn't matter which order you do them. If you did x squared minus 2x plus 4x minus 8, that's fine. Or you could write it out like I did, x squared plus 4x minus 2x minus 8, right? Whatever works. And the last step is just to combine the like terms. So x squared and 4x minus 2x, that would give you plus 2x, and then the minus 8. You guys can interrupt me if you've got questions or clarification. I mess up sometimes. I started recording this only just because I was worried we only had like 3 people in here, so I started panicking about people maybe not being able to get into the lesson. So feel free to interrupt it. We might not need it anymore now that you guys are all able to get in. I was just worried that Schoology was down and I didn't want people to miss it. So don't feel like you can't talk or whatever. I could probably even stop it. Okay, so then the next one. So we've got y equals x plus 4 times x minus 4. So same idea here, we're just multiplying. You could make a box, but this one is a little bit different, and I'll show you why. So there was one like this on your summative quiz. And a lot of you did okay, but I think there's a little bit of confusion, and I'll show you where and why. So if we multiply, we've got x times x, so that's x squared. 4 times x, that's 4x, negative 4 times x minus 4x, and then 4 times negative 4 is a negative 16. And then I'll pause there. If you are distributing, you'll take x times x, which is x squared, and x times minus 4, which is minus 4x. Then you'll take 4 times x, which is 4x, and 4 times negative 4, which is minus 16. Okay. So if you were right here at the box method, then you would just write each of these out, just like over here. If you have them flipped around, it doesn't matter, because when you combine them, right, 2 plus 3 is the same thing as 3 plus 2. Doesn't matter which order they're in. But we do have to combine those like terms, and here's where people get a little bit screwed up. Okay. Negative 4 plus 4, that is a 0. This becomes 0. So you don't rewrite that. You just leave the minus 16 and it cancels out. And that's your answer. Okay. So that's where people kind of get screwed up a little bit, but I'm going to do a side note over here. Okay. Do you remember when we talked about perfect squares a few weeks ago? I mean, it's been a minute, but we talked a little bit about perfect squares when we're factoring. So remember when I give you an example like, oops, I'm sorry. Let's say I gave you x squared minus 9. And I said, okay, well, if it's got a minus and it's a perfect square, you can just right away make your double parentheses to split up the x, and the square root of 9 is 3. So you'd put plus 3 and minus 3, right? What if I gave you x squared, then like even minus 16, just like the answer we just got here? Well, there's a minus, and the square root of 16 is 4. So I know I can just make it x plus 4, x minus 4. Crazy, right? So even if I went backwards with this, now that you guys might see that pattern, what if I did like x squared minus 25? You know that that's x plus 5, x minus 5, right? And then let's even go, let's think about it this way. What if we did x plus 10, x minus 10?
I have a question. So can we do it that way instead of doing it the box way?
If you see that pattern, right? So like look at x plus 10, x minus 10.
If it's a perfect square, can we do it like that?
I mean, yes, like you can. You just want to make sure, like if you see a number like 10 and 10, well, you know that's 10 times 10 is 100. The square root of 100 is 10. And you see that plus and minus, I know that this is x squared minus 100. I just know that, right? But that's also just from seeing the pattern and doing it so many times. Like when I see this x plus 4, x minus 4, I know that that's x squared minus 16, right? This is the process to get there, but math does have patterns too, right? Like, I mean, if you see the 4, you know 4 times 4 is 16. You see that plus and minus, so I know it's going to cancel out, right? But I'm just trying to show you those patterns and kind of how it works. All right. So looking at the next one. So now we're going from standard form to factored form. So we're going backwards from what we just did. Here we went from factored to standard. So the method that I taught you originally on that day one when we did this was the diamond method, which that works every single time, no matter what the problem is. However, the diamond method kind of sucks because it takes forever, right? It's just so many steps, and then you like forget what you were trying to do, okay? So if you can avoid that method, why not? So I think what I originally told you guys was go ahead and check if a equals 1. So what do I mean when I say check if a equals 1? Well, ax squared in standard form, so that's your ax squared, that's your bx, and that's your c. So c is negative 18, b is 3, and what's a equal to? Well, I don't see a number in front of the x, so that means it's a 1. If a is equal to 1, which of course we gave you the ones that a equals 1 on your summative, right? Of course, like we do the tougher ones in the homework sometimes than in notes, but on your test, right? We don't want it to be too complicated, or at least I don't. If a is equal to 1, you can right away go ahead and make your double parentheses to get it into factored form. These parentheses are kind of bad. Okay, and to split up that x squared, well, look at how we did it on question 2. right? The x's were split up, x times x, that gives you the x squared. So to split up the x, x squared, you just split them up. Then you start to think, okay, well, what multiplies to be negative 18, but adds or subtracts to be 3? So let's think about the factors of 18 first. We've got 1 and 18, 2 and 9, and 3 and 6. Okay. So let's think, which one of those could I get to be added to 3? Okay, well, not 1 and 18, there's no way. 2 and 9, probably not. Okay, well, 3 and 6. How would I get that to be 3? How about, let's try 6 minus 3? Well, that's 3. And is 6 times negative 3 negative 18? Yep. So we got it. And I'm going to put plus 6 minus 3. Now, what if I did it like this? What if I did minus 3 plus 6? Same thing. It doesn't, like that order doesn't matter. As long as the minus stays with the 3 and the plus is with the 6, you'll get the same answer. Okay. Awesome. We're almost done with our review. We've got 3 more problems to go. So hang in there. I know it's the end of the day. Nice stretch or whatever. Okay. So now, number 4, and this one was kind of like the one that was on your quiz. This says y equals 2 times x plus 3 squared minus 8. And what it asks you to do on that quiz question was it was asking you to compare it to x squared, right? That's your parent function, y equals x squared. Is this concave up or down? Does it go left and right? And does it shift left or right? And does it shift up or down? Right? I don't know if you guys who took the quiz, do you remember like it had all those check boxes and you had to check the ones that described it? Same idea. And there's one like this in the retake too. So you could do this without graphing it, right? Concave up or down. Well, what decides that is this is y equals a x minus h squared plus k. It's the a that decides if it's up or down. If it's positive, it's concave up, and if it's negative, it's concave down. Well, the 2 here, a equals 2, and that's a positive number, so that means it's going to be concave up. So for the sake of just what we're doing right now, I think I'm just going to circle concave up. I guess I could have written it too, but I wanted you to see what I was like debating between. Okay. And does it move to the left or the right? Well, that's the h that decides that, right? So this is a positive 3. And normally we would think that goes to the right, but because it's a positive 3, remember for the h, we always would flip the sign. So that means we're going to go left. And then up or down, if it's shifting up or down, that's the k that decides that. So because it's a negative 8, we're going down. Now, what if you couldn't remember those things? You're like, okay, concave up or down, it was something with one of the letters, left or right, I don't know, flip the sign, the K, like there's just a lot happening here. If you don't remember, then just put it in Desmos, both of them, y equals x squared to compare it, and then the new equation. And this is the last question I did, so I happen to have it here. But y equals x squared, that's the green line. So that's our original. That's the parent function. It goes through the origin 0, 0. There's no other pieces to it that could transform it. But then here's the problem we were looking at. So we're trying to compare the green to the purple. So if you were working at this on your own, you can look and say, okay, well, the purple one went to the left and it went down and it's concave up because it's opening up. So that's not super mathematical, right? That's just typing in something and making an observation. So don't overthink that too much. It's not meant to, stress you out. Okay? So if you're planning on doing the retake, I did put that video in there for you. But these could also be helpful too. They're very similar. Okay? And I'll upload these notes to Schoology for you as well if you missed anything or if you joined a little late. Okay, so new questions. So we've got 2 new examples. And we're going to be looking at modeling a situation. You do not need to write any of this down. You don't need to write this, like description here down and the directions, and then you don't have to draw this. I'm going to draw my own sketch. So whatever I write down, you can just write that down. You don't have to have this part. And if you needed it later, you could always just open it on Schoology. Don't take the time. Okay, so let's see what it wants us to do. So it says the diagram at the right shows a jackrabbit jumping over a 3-foot high fence. Just to clear the fence, sorry, the rabbit must start its jump at a point 4 feet from the fence. Your goal is to sketch the situation and write an equation that models the path of the jackrabbit. What is the shape of the path of the jackrabbit, and what kind of equation would best model this? So we're going to do 2 problems just like this one, and they're almost identical. And I'll show you like which parts I think are easier and then where it gets a little bit tricky. Okay. So it does say here that your goal is to sketch the situation. So why don't we sketch this maybe a little bit more, I don't want to say that this isn't mathematical, but this isn't totally describing what it would look like if we were using a graph, right? So let's go ahead and I'm going to draw a graph. And all we need for these is just the quadrant 1 of a graph, right? Because we're going to be talking about time and distances. If you think about like your coordinate plane, and you've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4, which if you're taking the ACT this year, I would bet money that they're going to ask you which quadrant something is in. Okay, so remember it goes 1, 2, 3, 4. Okay. Well, we're only working with positive numbers right now because we're talking about time and distance and that kind of stuff with these problems. So I only need quadrant 1. So that's why I just drew this one. Okay. All right, so now let's draw it. So we've got our rabbit, and the rabbit's going to start at 0, 0. And it says that the rabbit jumps, and what I can see is the rabbit jumps a total of 8 feet. So I'm going to draw an 8 here. Now my vertical distance, what's the highest point that the rabbit has to jump? Well, that's 3 feet. So I'm going to put a 3 here. Okay. All right, so if you remember what I said at the beginning of class, one thing that I was talking about was if we're looking at a quadratic situation and it's concave down, which is what we're doing for these 2 problems. You have a point here. That point is your vertex, your H and K, but it's also your max point as well as an axis of symmetry. Okay, so when it says that like the max height that the rabbit has to jump is 3 feet, that means right in the middle is that highest point that the rabbit will be. So that tells me right in the middle, the rabbit will be at 4 feet. I'm sorry, 3 feet. So when I jump, it looks like this. Sorry, I keep saying I mean the rabbit. Okay, so that vertex point, I've almost found it, right? That's my maximum point. That's my axis of symmetry. But I also need to know my H and K point. 3 is the K point because it's the height. But what about this point, right? What about the H? So that's always right in the middle. Okay, so that means that this number is going to be 4, which makes that 4. So it does want us to write an equation. And the equation to use that best models the situation would be vertex form. Because we have a vertex, right? You could technically use intercept form as well because we do have the 2 x-intercepts, but I think vertex form is easier. So vertex form, I'll write that down.
I have a
Y.
question.
Yeah, go ahead.
So will it always be like a number you can divide in half by 2? Will it always be that?
Yeah.
Okay.
There have been problems in the past where like you divide it in half and you end up getting like a point that's a decimal, but I haven't seen any that you guys are working with like now or in the future that have that come up. But I mean, it could happen where you get a decimal and that would be fine, but not really in these cases. I was writing a question yesterday for your practice quiz, like next week or the week after, and it's about flying fish. And it did have some decimals, so I just changed the numbers around so it wouldn't. So there you go. Okay, so we've got vertex form. And I'm gonna write out these like steps for you. So when you were doing, if you try one of these problems on your own, you'll be able to reference this and then have the steps. So the very first step, so when you're writing an equation, you need to find an A, H, and K, right? If I were to tell you write an equation y equals mx plus b, you would fill out the m and the b, right? Same idea. Okay, so step one, we're going to plug in the vertex. Okay, so you can write that if you'd like to. And that's y equals, so we don't know a yet. That's not part of our vertex. The vertex is the h and k point, which we found before, right? So that's x minus 4 squared plus 3. So I've got my A, H, and K. Okay. Now for step 2. What are we missing? Well, we don't have A, right? So an A is tougher to find because we can't necessarily see A on our sketch. We aren't going to know what A is. We actually have to find it. So find A is step 2. And the way you do that is by plugging in 0, 0 for x and y. And while you're writing that, I'll explain a little bit more. Like, I want you to find A, which would mean getting A all by itself and solving an equation. Like, let's say I said find x. Well, you would get x by itself using your algebra skills. But the problem here is we have way too many variables, right? How could, like, even if I can get A by itself, but we're still going to have an x and a y, and we're not going to know what A is equal to. So every time, now there's other points you can use too, but 0, 0 is the easiest one for solving. So every time you're going to take 0, 0, and you'll plug it in for x and y. So what that looks like then would be 0 equals A times 0 minus 4 squared plus 3. And we're still trying to find A. Okay. So the next step here then is to start to solve for A. And before we start doing like an algebra equation, like in those steps, I think we need to do a little bit of simplifying, which involves like PEMDAS stuff, right? So PEMDAS tells us we need to look at any parentheses first. Do we see parentheses? Yes, there are parentheses here. So what I'm going to do, I think 0 equals A, and I'm just going to do what's inside the parentheses, and that says 0 minus 4. 0 minus 4 is negative 4. Okay. And yay, did it. So then PEMDAS tells us next that we need to look for any exponents. Are there exponents? Yes. We've got negative 4 squared. So negative 4 times negative 4 is a positive 16. So I'm going to rewrite this. Now we're almost ready to start solving our equation, but there is some multiplication we could do. Having A16, that's kind of weird. It sounds like bingo or something. That's not what we do. So we're going to kind of do the multiplication stuff, but the way we do that is, so A16, all that is 16A. That's all that is. Okay. So I'm going to zoom in a little more so I can write a little bit neater. So I'm just going to rewrite that. I'll keep highlighting A so you know what we're solving for. I'm going to rewrite this as 16A and then plus 3. So remember our goal. We are just trying to get A by itself. That's it. Okay. Now I'm ready to start solving. Like I could put a line here through my equals and work on getting A by itself. But for whatever reason, people really don't like solving equations this way. And then there's a 0 and it kind of screws people up. So if you need to, you could, here's a side note. That is the same thing as 16x plus 3 equals 0. And I'm even going to use an x because that's how much we've solved equations like that, right? So you can even put a line through there. And I'll show you how I'm solving both ways just because I want you to see that it's the same thing. So over here, right, you would start by subtracting the 3. You work with whatever's being added or subtracted first to the variable you're trying to get by itself. So that would be the 3. So I've got 16x equals negative 3. If I do that over here, I'm subtracting 3. So I have negative 3 equals 16a. Now I'm going to divide by 16. So it cancels. I'm over on the other side. Okay, so I hope you guys see how I did that. And did I get a weird decimal number, or sorry, fraction number? Yeah. Yeah, I did. And you're going to when you solve these questions because this is talking about the width of a parabola, right? You already knew it was going to be negative because it's concave down. But when we're talking about widths of a parabola, that could be literally anything, right? That's going to be the one number that really doesn't work out that well. And that's fine. It's actually kind of preferable because then it's not like you have to, I don't know, it is what it is, right? So then the very last step would be, I'll just write it over here. Step 3, I'm kind of out of room. Step 3 would be write equation. And that's just where you plug in everything. So that would be y equals negative 3 over 16 times x minus 4 squared plus 3. Whew. Guys, we did it. Mostly me, but I'll call it a group effort. You guys are there in spirit. Okay, we've got one more. Do you guys have any questions about that or you just want to see it again? It's going to be the exact same steps the next time, just different numbers. Okay. All right. So example 2. And again, you don't need to write all of this stuff down. Just write down what I'm writing down. And if you want to look back at what the problem was later, just open up the notes. That'll be in Schoology. Okay. So it says when Miss Pernick kicked a soccer ball, it traveled a horizontal distance of 150 feet and it reached a height of 100 feet at its highest point. So sketch the path of the soccer ball and find the equation of the parabola that models it. Okay, so it says sketch the path and then find the equation. So we'll start with a sketch, which that makes these problems way easier anyway. So we can have a visual. So I'm going to do the same thing where I just make quadrant 1 of an x and y axis. And now let's look at the story for some clues. So I see that it traveled a horizontal distance of 100 feet. So horizontal is our x-axis. So that tells me if I'm here with that soccer ball and I kick the soccer ball, it will land there. And then the other clue is the height of 100 feet at its highest point. Highest point, maximum point, right? Those mean the same thing, and that's what we're looking for. Oops, I'm sorry. Okay, so I'll put a 100. So what that tells me is right in about the center, I'm going to be reaching my maximum point at 100 feet. So when I kick the soccer ball, it's going to look something like that. Now, if I was trying to model this in Desmos, obviously it would look much, much more accurate. This is a sketch. I really want to emphasize the word sketch because I can't draw very well. So, okay. So what we're looking for is that vertex, right? So we've got something 100, and we know that this is our axis of symmetry. So it's whatever is in the middle of 0 and 150. So if you take 150 divided by 2, you would get 75. So now with this information, we're going to do the same steps as we did last time. So you could even look like at the question above. What did I say to do? Okay, vertex form. So I'll rewrite that so you've got it. So that's y equals a times x minus h squared plus k. And we need to fill in the a, h, and k. Okay, so step 1 shows you to plug in the vertex. So that's your h and k. So this now looks like y equals a times x minus 75 squared plus 100. Right. And then step 2, I wrote find a. So you plug in 0, 0 for x and y. If you want to write ahead of me a little bit, you can, just to like kind of see if you're getting it a little bit, even just trying to plug this stuff in. It should look like 0 equals a times 0 minus 75 squared plus 100. Okay, and our main goal here is we're trying to get a by itself. Okay. So even just like what I said last time, before we can start like solving, let's simplify. So to do that, let's think about our order of operations in PEMDAS. So what would I do first? Let's look at the parentheses. Okay, there are parentheses, so we can start solving with that. So that would be 0 equals a times negative 75 squared plus 100. Parentheses done. Let's look for an exponent. There is an exponent right here. So even if you need your calculator, that's fine. Or even on your phone, you could take negative 75 times negative 75. So let's simplify that. So that gives us a times, and that would be 5,625 plus 100. The only other thing that we would want to do, so we took care of the exponent. We're not technically multiplying, but I would say it kind of is. We need to flip those two around. So if you remember what I said before, a times 5,625, that would just be 5,625a. Because we don't really write it the other way. That's kind of weird. Okay, so I'm going to rewrite that. Okay. I don't know if this is helpful for you guys or not, but even if it's helpful for one of you, it's worth doing, right? Just rewriting it a little bit, having 5,625x plus 100 equals 0. just so you can see what they both look like, so you could maybe start, you know, really not feeling intimidated by it, because I feel like for whatever reason, we never really solved equations like that prior to Algebra 2, so this just like looks weird compared to this. Okay, so if you're at that point and you like to write the line between your equal sign, that's totally fine. Go ahead and do that. And if you want to work ahead of me and see if you can get it, please do, just to check yourself a little bit. But whichever one we're looking at here, we're going to subtract 100. And remember, we have to do that because when we're solving for the variable, we have to get rid of what's being added or subtracted first, and then we multiply and divide. Okay, so we're going to have negative 100 equals 5,625a, or just, you know, over here, if you're thinking about it this way. Okay. And then that last step, to get a by itself, well, it's being multiplied. So to undo multiplication, we have to do division. I'm going to do that all the way around. Sorry. Okay. All right. And like I said, you're going to get a weird number, and that's fine. Okay, so now we have a, we found it, and step 3 would be to write the equation. So now with all of our pieces, now that we know a is negative 100 over 5,625 times x minus 75 squared plus 100. So we've got our a, our h, and our k. And there we go.